Hello, my name is Jonathan, and today me and my partner Ian will be teaching you Unit 8.4, which is the intersections of lines in 2 space and 3 space. For this lesson, we will be using the parametric equation and the vector equation in both 2 space and 3 space, as well as another equation you will learn further on in the lesson. So how do you determine how many solutions will be found in 2 space? Well, you'll find one solution when 2 lines intersect. You'll know this when you solve and you get an x value or a y value, which could be x is equal to 1 or y is equal to 2. And when you sub it back into the equation, you get a point of intersection. Now, another option is infinite solutions. This is when both lines are coincident, meaning that they're overlapping and they're practically the same line. You'll know this when you solve and you get answers such as 0x is equal to 0 or 0y is equal to 0. For both x and y values, it doesn't matter what number they are, when they're multiplied by 0, it's always going to equal 0. So since the left side equals the right side, both lines will always be intersecting. And the last one would be no solutions. This is when both lines are parallel and distinct. They're both different lines, and they're parallel. So this would be found when you solve and you get equations such as 0x is equal to 1 or 0y is equal to 1. But the value here could be any number. This is true because for any value of x and y, they're always going to be multiplied by 0, meaning that the value can only be 0 and the left side will never equal the right side, showing that both lines will never intersect. For example 1, we're going to be classifying each system of lines having either a 0, 1, or infinite solutions. Here we have 2 lines in y equals mx plus b form. 3x plus 12y, which is equal to negative 27, and 4x plus 2y, which is equal to 34. Now, the method of choice would be elimination, and the easiest variable to eliminate would be y. So that means we're going to multiply this entire equation here by negative 6, which would give us negative 24x minus 12y, which is going to be equal to negative 204. Now, all we have to do is we have to add up equation 1 with our new equation, which is going to give us negative 21x, and the 12's cancel out, which is going to be equal to negative 231. Now all we do is isolate for x. So we divide both sides by negative 21, and our x is going to be equal to 11. Now that we have this, we just sub this into any one of our equations. So let's try number 1. So 3 times 11 plus 12y is equal to negative 27. We have 33 plus 12y is equal to negative 27. And when we take 33 to the other side, we're going to get 12y is equal to negative 60. Now we divide both sides by 12. And y is going to be equal to negative 5. Now since we found both our x and y values, we already know there's going to be one solution. And that's going to be 11 and 5 as our point of intersection, or 11 and negative 5. Moving on to part B. We have both our lines this time in our vector equations. So we're going to have to make our parametric equations for both lines. For line 1, the parametric equations are going to be x is equal to negative 12 plus 8s. For y, it's going to be equal to negative 7 minus 5s. For line 2, it's going to be x is equal to 2 plus 3t, and for y, it's going to be equal to negative 1 minus 2t. So now, we equate both the x equations and the y equations, which is going to give us negative 12 plus 8s, which is going to be equal to 2 plus 3t. And for the y's, it's going to be negative 7 minus 5s is going to be equal to negative 1 minus 2t. Now, we're going to bring the variables over to one side and the constant onto the other side. So for equation 1, we're going to get 8s is going to be 8s minus 3t, which is going to be equal to 14. And we're going to have, for equation 2, we're going to have negative 5s plus 2t is equal to 6. Now, we're going to use elimination. So the easiest to eliminate would be t. So we'll multiply this equation by 2 and this equation by 3. And that should give us 16 is equal to 16s minus 6t is going to be equal to 28, and negative 15s plus 6t is going to be equal to 18. Now we're going to have s is going to be equal to 46. Now that we have s, we already know that there's going to be one solution. So now we can find t. So we'll use any equation. This time we'll use 2. So negative 5 times 46 plus 2t is going to be equal to 6. So this is going to give us negative 230 plus 2t is equal to 6. And then 2t is going to be equal to 236. Divide both sides by 2, and we're going to get 118 as our t value. Now we can plug either or into our parametric equation or our vector equation, whichever one, and we should get our point. So if we plug 46 into our parametric, we'd get x would be 356, and then we would get our y to be negative 237. And this right here, this would be our point of intersection. Now, moving on to 3-space, it follows the same concept really. For when there's one solution, the lines intersect. When there's infinite solutions, the lines are coincidental. And when they're parallel, there's no solution. But there's a fourth option, which is when the lines are skewed, and that's when they're not parallel and they do not intersect. But that also yields no solution. Skewed is pretty much when you have a line that's either above or below a line that are not parallel and do not intersect at any point. And we'll cover this further on in the lesson. Moving on to example 2, we're going to determine if two lines in 3-space intersect. So once again, we're given the vector equations of our two lines. So like the question before, we're gonna make our parametric equations, but this time we're gonna make one for the z coordinate. So we're gonna have, for line 1, x is gonna be equal to 7 plus 2s, y is just gonna be equal to s, and z is going to be equal to negative 15 minus 5s. For line 2, x is gonna be equal to negative 7t. Is gonna be equal to 7 plus 2t. Y is going to be equal to negative 7 plus t. And z is going to be equal to 20 minus 5t. So now what we do is we're going to do the same thing. We're going to equate the like equations, and we're going to get 0 is equal to negative 2s plus 2t. For equation 2, we're going to get 7 is equal to negative s plus t. And for equation 3, we're going to get negative 35, which is going to be equal to 5s minus 5t. Now, what we're going to do here, since we have three equations, we're going to isolate the first equation for s, and then we're going to sub that value into the other equations to find the values of t. So, if we isolate, we're going to get 2s is equal to 2t. We divide both sides by 2, s is going to be equal to t. So now, we're going to sub it in to each of the other equations. So for equation 2, we're going to have 7, which is going to be equal to negative t plus t. And the answer for that is going to be 0t is equal to negative 7. For equation 3, we're going to have negative 35 is equal to 5t minus 5t, which is once again going to give us an impossible answer, which is going to be negative 35 is equal to 0t. So just by looking at both of our t values here, we can already tell that there's going to be no solutions, as for any value of t, it is impossible to get negative 7 and negative 35. So therefore, these two lines right here, these do not intersect, and it means that they're parallel and they're both distinct lines. Now for example 3, we're going to determine if the lines are skew. So once again, we're given two lines in their vector equations, and the same thing, we have to find their parametric equations. So the parametric equation for line 1 is x is equal to 5t plus 6s, y is equal to negative 4 plus 4s, and z is equal to 1 minus 2s. For line 2, we have x is going to be equal to 2 plus t, y is going to be equal to negative 3 plus 2t, and z is going to be equal to 4 minus 3t. So now if we equate the respective equations together, we're going to get equation 1 is going to be 3 is equal to negative 6s plus t. Equation 2 is going to be negative 1 is equal to negative 4s plus 2t. And equation 3 is going to be negative 3 is equal to 2s minus 3t. So now we can choose any two equations we want to isolate for a variable. So I'm going to choose 2 and 3. So for 2, it's going to be negative 1 is equal to negative 4s plus 2t. And for 3, it's going to be negative 3 is equal to 2s minus 3t. Now, all we have to do is we'll isolate for s. So all we have to do is multiply this equation by 2. So now we're going to have negative 1 is equal to negative 4s plus 2t. And then it's going to be negative 6 equals 4s minus 6t. So now we're going to get negative 7 is equal to negative 4t, and then we divide both sides by negative 4, and t is going to be equal to 7 over 4. Now we can plug it back into any of the two equations, 2 or 3, and find s. So now we'll plug it into equation 2. So when we plug it into equation 2, we're going to have negative 1 is equal to negative 4s plus 2 times 7 over 4. That's going to give us negative 1 is equal to negative 4s plus 14 over 4. Now we have to get common denominator, but let's take 4s to the other side. So we're going to get 4s is equal to 1 plus 14 over 4. And now we're just going to get, if we get this, we're going to have 4 over 4, which is going to be 4s is equal to 18 over 4. And then we divide both sides by 4. So s is going to be equal to 18 over 4 divided by 4. And we're going to end up getting 18 over 16 as the value for s. Now we plug both of these back into the first equation, and we see if the left side is equal to the right side. So for the first equation, 3 is equal to negative 6s plus t. So the left side is equal to 3. Now let's figure out what the right side is going to be equal to. So the right side is going to be equal to negative 6 times 18 over 16 plus 7 over 4, which is going to be equal to negative 108 over 16. And then if we want the same denominator, we multiply this by 4 and this by 4, so we're going to get 28 over 16, which is equal to negative 80 over 16. Now when we divide these two, we get our answer as negative 5. And since the left side does not equal the right side, we have skew lines. So therefore, we have skew lines.
Okay, now that we know that skew lines are not parallel but non-intersecting 3D lines, we can find out their closest approach. The information we have given so far are the equations of the two lines, in which we could find M1 from, which is 1, 2, and 3 as given here, and M2 as 2, negative 1, and 1 as given here. Those are the directions that the line travels, and a point from each line. So point 1 would be 5, negative 4, and negative 2, and point 2 being 2, 0, and 1. You can then find out that the normal to both lines is their directions crossed, which is M1 cross M2. And we know that their closest approach would be when both lines are perpendicular to this normal line. In this diagram, we can show that AB, which is the distance we are looking for, is parallel to N. and that P1, P2 projected onto N will result in the magnitude of AB. Then we can use the projection formula, which is P1, P2 dot N over the magnitude of N equals the magnitude of AB, which is the distance. Then we can sub back in M1 cross M2 into N, since we know that N is both perpendicular to both the directions of the lines. So for the next step, we'll have to find out the N value, which we'll have to cross M1 and M2, given that M1 is 1, 2, and 3, and M2 is 2, 1, negative 1, and 1. For this, we'll apply the crossing method to get the formula for cross product. And then we'll simplify into 5, 5, and negative 5. And since we are only taking the direction, we could divide by 5 for convenience when we plug it back into the formula. Next, we'll have to find the vector that connects point 1 to point 2. For this, we'll have to subtract point 2 from point 1. So 2 minus 5 will result in negative 3. 0 minus negative 4 will result in 4. And 1 minus negative 2 will result in 3. And the vector that connects the line will be negative 3, 4, and 3. After having solved for both N and P1, P2 in their vector form, we can finally solve for the distance of A and B. For this, it will be P1, P2 dot N over the magnitude of N. So we take the vector form of both, and for the magnitude of N, we would add up all the components squared and then square root them. So we on the bottom we would have 1 squared plus 1 squared plus negative 1 squared, all under square root, which will result in square root 3. And for the top, for dot product, we would have negative 3 times 1 plus 4 times 1 plus 3 times negative 1, shown here. And then simplified, it would be negative 2. Since we're taking the absolute value, it will be 2 over square root 3, which will give us a final value of 1.155. In this section, I'll be covering the intersection of 3D lines. So first you are given the equations of two lines, which must be put into parametric formulas. So x equals 7 plus 2s, y equals 2 plus s, z equals negative 6 minus 3s for line 1, and for line 2 it is x equals 3 plus t, y equals 9 plus 5t, and z equals 13 plus 5t. Next you must equate the like coordinates. So for the x-axis you will have 7 plus 2s equals 3 plus t, which will be simplified to 2s minus t equals negative 4. For the y-coordinate, you would have 2 plus s equals 9 plus 5t, which will be simplified to s minus 5t equals 7. And for the z, you'll have negative 6 minus 3s equals 13 plus 5t, which will be simplified all the way down to 3s plus 5t equals negative 19. For this, I would like to have the s and t in positive because I will be using substitution method later with them. So the next step is to finding out the values of s and t. So for this, there are two methods, elimination and substitution. So elimination involves adding two of the formulas found out above and isolating for one variable. So we can easily do this with formula 2 and formula 3 due to how it's positive 5t here and negative 5t. So when we add it together, it will result in 0t. As shown here, when we add it together, s plus 3s is 4s, negative 5t plus positive 5t is 0t, and 7 minus 19 and plus negative 19 equals negative 12. So for this, we have now 4s plus 0t equals negative 12, which is basically 4s equals negative 12. And then we can isolate for s and find out it is negative 3. Next, we could sub back in our new s value into this equation, s minus 5t equals 7, and isolate for t, and then we find out that t is negative 2. So for the second method, substitution, we will take any of the three formulas and isolate for one of the variables. So for this, I chose formula 2 and I isolated for s, resulting in s equals 7 plus 5t. Then I substituted back in the s value into the first equation here and found out that 14 plus 10t minus t equals negative 4 after all the simplifications. Then I would isolate one side for the t value, and I would find out that t equals -2. And then I could plug this t value back into this formula, and I will have 2s plus 2 equals -4. And then when I isolate for s again, I found out that s equals -3, shown right here. So now I know that both methods work because they result in the same values. So we would have to perform a check to make sure there is an intersection at the given t and s values. So for this, you would choose any of the formulas previously found out and sub in back t and s. For this, I chose 2s minus t equals -4, and our t value was -2 and s value was -2. Then I made sure that left side equals right side. If it does equal, that means it is not a skew line, and we know that there is an intersection on these two lines. For the final step, we will have to find the point of intersection. For this, we would take either line 1 or line 2, the given equation at the beginning of the question, and sub in back our s or t value for each respective line. So for line 1, the value we needed was s. So we sub back in -3, and then we expanded and simplified, and we found out that the point of intersection is 1, -1, and 3, meaning that this line was not skew and it has one distinct point of intersection.